Thank you, Eva. Thanks. Good morning. My name is Max. I'm the CEO of Assaia International. We're a Zurich-based startups, and we teach computers to understand the world like we humans do. In order to achieve this, we use a technology that's called neural networks, commonly referred to as artificial intelligence or machine learning. Why is it that Google, Facebook, and Amazon are taking over the world? I think one major answer to this question is that they've created a system to extract information from us, extract data from us and from other systems, collect it, enrich it, and then leverage it to a great economic success. To give you an example for the system, if you scroll through your Facebook or LinkedIn feed today, what you will see is based on tens of thousands of A/B tests these companies have carried out over the last years. The platforms will show you exactly that content that ensures that you will spend the maximum amount of time on these platforms, because this translates into the maximum revenue for these platforms. What's important to understand is that we're currently on the threshold to a new era. So far, most businesses have worked purely based on structured data, such as spreadsheets, sensor data, or booking systems. Now, what's interesting to know is that actually this type of data, structured data, makes up for only 20% of all the data that exists in the world. The other 80% of data is unstructured data, such as camera recordings, such as sound or images. Machine learning, the technology that's currently very much in hype, will allow us to actually tap into this type of data and work with it very similarly to how we work with structured data. So this will be a huge game changer. It will open up the access to the last 80% of the data on this planet. To give you an idea of the economic magnitude, I will take around 10 minutes today to finish this presentation. And within these 10 minutes, Amazon's Alexa will have collected transactions that are worth $100,000 for Amazon. This is purely based off of voice commands that actually order stuff off of Amazon. And in 2 years' time, the run rate will already be $500,000 in revenue from Amazon, purely based on voice data. So it's pretty huge, actually. Now, why am I telling you all of this? Well, it turns out that the aviation industry sits on a huge pile of unstructured data, and we believe that there's enormous value in this unstructured data. Examples for this are recordings of communications between pilots and towers, for example. And another major example is CCTV footage, video footage that is created in terabytes and terabytes each day, and that we think we can leverage. So as a first step to unleash the value that's hidden in this unstructured data for the aviation industry, we're taking video footage, video recordings or live footage from ramp cameras, and we taught computers to watch these video footages, understand what's happening on this video, and based on that, create certain actions or deduct certain information or data off of it. So one example of what we're doing is we're feeding this video feeds into the neural network that we've created. And this neural network will then detect every single event that's happening during a turnaround and will provide you with exact, reliable, and unbiased timestamps for each event that has happened. Another example is that we taught the computers to understand what a hazardous situation looks like. For example, someone wandering around the apron without having his warning vest wearing, or equipment that is stowed isn't stowed properly ahead of an airplane arriving and could cause damage. So these are two examples where we taught the computers to understand what's actually happening on these videos. At this point of the presentation, I'd like to give you a quick demo of how our solution actually works. So what you can see in the left upper side is a turnaround, a video of a turnaround. It's a little bit accelerated. And you can see that as events happen, these events are detected by the algorithm, and they are timestamped, as you can see in this Gantt chart to the right. And you can see that this is working at a pretty high resolution because we can also identify individual containers that are leaving the airplane. Furthermore, you can see that we get structured data out of this process about the timestamps, so you can patch this information directly into existing systems. How it works, a quick summary for you. As I mentioned, we're taking the ramp video feeds. These could be from any cameras. It doesn't matter what kind of resolution they have. It doesn't matter that they're already pre-installed. It doesn't matter what the conditions are. We just use this information. We patch it through a neural net. So this combination works in a very primitive manner, like the combination of a human eye and a human brain does. It just understands the things that are happening that we trained before. And out you get structured data that you can then import directly into your existing systems. You can look at it on a spreadsheet, you can share it with your partners, and you can also use it to trigger real-time alerts so that you can prevent accidents. At this point, I'd like to introduce Florian to the stage. Florian is the head of innovation of Swissport International, and he's going to brief you on how the system actually performs in the real world and what the benefits are.
Thank you, Max. I'm excited to be here. Swissport's not a tech company, but we want to partner, and we are partnering with those that are, especially startups like Assaia. So I'm happy to share with you our motivation behind developing this solution for the industry. At the end of the day, it's a way for us to drive profitability and reduce accidents. By having an algorithm that understands in detail what is happening on a video, there are a wide range of use cases for us ground handlers, airports, and airlines. First of all, we're able to have we're able to optimize our contracts by having better structured, maybe also more complex, especially service level agreements, because we can easily track the timestamps that are necessary to govern an SLA so that we can be rewarded for going above and beyond or penalized if we don't hit the targets. We're also able to use these timestamps to capture services that we provide, especially those ancillary or ad hoc services that tend to lead to revenue leakage. And speaking of invoicing services, we can also then use these automatically generated timestamps to help our admin staff behind the scenes, because usually there's significant effort happening behind the scenes to govern SLAs and to invoice for services. Thinking longer term, we're able to optimize our service levels even further, because by having footage and data on hundreds of turnarounds of the same plane, we're able to understand better where we consistently get things wrong so that we can start with corrective actions. It's also a way for us to optimize the usage of our fleet in conjunction with telematics that we've been implementing at Swissport. And last but definitely not least, it's a way to prevent accidents before they happen. Because the most prominent use case for CCTV is to investigate accidents that have happened. And I'm sure many of you have gone to an airport OCC to look at footage of when things went wrong and thought, oh man, this could have been prevented. Well, by having an algorithm understand what is happening, you can flag situations before they happen, such as FOD, such as equipment inside the ERA, or by having an employee walking between dollies, for example. You can trigger that real-time alert to the person on the ground so that they can step in. So to summarize what we see as the key features for us, and by the way, if you want to take a picture of the presentations, that's the slide you want to grab. There are the timestamps. So it's having real-time timestamps, unbiased timestamps, and especially near endless amount of timestamps that we can't get today, automatically fed into your systems, whichever systems you might have in production. It's also a single source of truth, so that there shouldn't be a blame game between different providers of who did what wrong. On the other side, there's the accident prevention element, because the algorithm continuously monitors the situations and flags potentially dangerous situations. And for us as a global ground handler, it's also very important that it's scalable. We can tap into existing camera infrastructure, be it airport CCTV, where they allow it, or otherwise we can put up consumer-grade hardware to capture video feeds. What's really exciting is that the algorithm is self-learning, so the more material you feed into it, the better it gets at understanding what is happening. And then, of course, it's also robust against climatic situations. So no matter if it's raining, snowing, or nighttime, as long as the human eye can see something on the camera feed, so can the algorithm.
Florian, thank you so much. So at this point in time, I invite you to try out our demo yourselves. You can just visit the URL that you see behind me. You can visit it on your smartphone or your laptop computer and get a feeling of what we're doing and how it works and how it looks like. Thank you so much for listening. I will be mainly at the couch area right in front of the main conference area. So if you want to get in contact, if you want to have a discussion, I'd be very delighted and honored to join the conversation with you. Thank you so much.